All right, in this video, we're going to go over radian measure. So we're going to start off with our intercepted arcs. And so an intercepted arc is just going to be an arc of a circle with your endpoints being on the sides of your angle. And the other points are going to be on the interior of that angle. Okay, so just using this picture down below here, if we have our angle right here, the intercepted arc to that angle would just be, we've got our endpoint, so where we land on the circle, and then just everything in between. All right, moving into our radian. We have that a radian is going to be the measure of a central angle that's going to intercept the arc with a length that will be equal to the radius of that circle. 1 radian is going to be the measure of a central angle that will intercept an arc with the length equal to the radius. And so we're going to recall here that a circumference of a circle is going to be 2 pi r. Therefore, 360 degrees will be our 2 pi radian. And then our 180 degrees will be equal to pi radian. The radian measure of a central angle of a circle is going to be the ratio of the arc length of your intercepted arc and the radius of the circle. Okay, so we have here that our radian measure is equal to the arc length divided by the radius. And so we commonly use that theta, we mentioned it in our previous unit using trigonometry, okay, to stand for an angle measure, will be equal to, and you will commonly use the letter S for arc length, divided by r, your radius. Okay, so once again, just mentioning we have that symbol theta, which is just going to represent the angle measure. All right, down below here we have some practice problems. Okay, so for number 1 and 2, we have use the circles below. What is the measure of theta in radians of the central angle? Okay, so here we have our theta is going to be equal to our arc length, which is that 4 pi inches, divided by my radius, which is that 6 inches. Okay, so what we need to do here is just reduce to find our actual answer for our theta. Okay, so here 4 and 6 are both divisible by 2, and so we'll get that theta is 2 pi over 3 radians. And you can also just use rad as well. Okay, moving into number 2 here, same idea. You have that your theta is equal to your arc length, 5 pi, divided by my radius, which is 15. Okay, so just reducing that fraction here, we're going to get theta is going to equal to pi divided by 3 radians. All right, now let's move into number 3 here, where they are using the circle to the right, and they're asking for us to find the arc length of, we have S in terms of pi, and then we'll do the same thing for the arc length of B in terms of pi. Okay, so starting off here, we'll have for S, we have that our S is going to be this arc here, which will be using the theta of 5 pi over 6 radian, and my radius of 3. Now, before I start working through this, okay, I'm going to look real quick at the formula that was given earlier, that theta is equal to S divided by R. Now, what I can do here is, so that I can solve for my arc length, my S, I'm going to rewrite this by multiplying that R to both sides to get that my S is just going to be equal to theta times R, my radius. Okay, and so plugging into it, we would have that 5 pi over 6 radian times my radius of 3 will just be equal to 5 pi divided by 2. Okay, so since this is my arc length here, we will need our units, so I'm going to put meters on the end. Okay, and just to clarify what I did here, okay, I had that multiplying by 3, and since I was dividing by 6, I just reduced that here, 3 divided by 6 to get into 1/2, and so that's where I got the 2 in my denominator. Moving into part B here, we're going to do the same thing, but for the arc length of B. Okay, so that's going to be using that 2 pi over 3. Times, once again, my radius of 3, which will just be equal to 2 pi meters. Okay, and to clarify once again, I have that 1/3, and so when I multiply by 3, it's just going to cancel out, and so I just was left with the 2 pi, and then making sure, since it is arc length, that I have my units. All right, before we move into converting, I just want to mention something. And so in a previous lesson, we had talked about how arc length, when in degrees, we have the formula. So I'm going to write this for you. We have that my arc length, my S, is equal to m 2 pi r over 360. Okay, and so just to clarify here, these are two different formulas, but you will see with this formula here with my degrees, how we're able to convert that into what they're telling us here with the S is equal to my theta times R. Okay, so keep in mind here that when you are dealing with radians, that 360 is equal to 2 pi radians. And so we have the m, which in this case is our theta, is what we've been using, times that 2 pi r divided by, we can convert that into 2 pi. And so you'll see here that we have this 2 pi in the numerator and in the denominator, and so they're canceling each other out. And so this is how we are ending up with the fact that our m, or like we're using theta, times r, my radius, will give us the arc length. Okay, so it's not two different formulas, it's just a different way of seeing it depending on if you're dealing with radians or degrees. All right, now let's move into our converting from radians to degrees and degrees to radian. Okay, so to obtain the conversion factors that will allow us to change back and forth from our degrees to our radians, we divide both sides of the last equation that we had written down up above, alternating by 180 and pi. So the last one that we had written out was that pi radians was going to be equal to 180 degrees. So what I'm looking at here is that on this side, we are dividing that equation by pi on both sides, and you should be left with that 180 divided by pi is equal to 1 radian. On the right side here, we are dividing both sides by 180, and when you do that, you're going to get 1 degree is going to be equal to the pi divided by 180 in radian. Okay, so you can use proportions here, okay, as they're showing you, to convert between the radians and the degrees. And then we also have here converting from radians to degrees that you can just multiply by a fraction as well. Okay, so it's up to you on how you want to do it. Personally, I like just multiplying by the fraction. And so the key thing, as long as you know that 180 degrees is equal to pi radian, it's just all about what are you trying to cancel out. So on converting my degrees to radians, you want to cancel out the degree symbol that you currently have. And so that means I want the 180 degrees, the degree symbol, in the denominator so that they cancel each other out. When I'm converting from my radians to degrees, I want the pi radians to disappear. Okay, so I'm going to have my radians and I'm going to just multiply it by 180 over pi radians so that they cancel each other out with that division. All right, let's look at some practice problems. So here with number 4, they want to know what is the radian measure of 27 degrees, and we're going to leave our answer in terms of pi. Okay, so we're going to start off with that 27 degrees, and we're going to multiply it by pi divided by 180. Okay, like I said, here you'll see that that degree that we currently have, I want to cancel it out, so I'm going to have it in my denominator. And then I'm just going to multiply. Okay, so I'll get 27 pi divided by 180. Okay, to make sure that this is my final answer, remember you want to see if you can reduce that fraction any. And so if I look at it, 27 and 180 are both divisible by 9. And so this should reduce down to 3 pi over 20. And then we'll have that radian or rad on the end since we are converting to radians. All right, looking at number 5 here, they are asking what is the degree measure of an angle that is 3 pi over 4 radians. So we're going to start off with that 3 pi over 4. Radians. And since we want the pi to cancel out, we need the pi in my denominator. And so I'm going to have 180 over pi. Okay, so I'm going to rewrite this. And here what I'm noticing is that these two, and to clarify, I'm not cross multiplying, but these two here, 180 degrees, we can divide it by the 4 that we have here. And so I'm going to be left with 3 times, and then that 180 divided by 4 is going to leave me with 45. And my pi disappears because kind of in the same idea, when I had the pi in the numerator here, but over here in the denominator, they cancel each other out. And so now I just need to multiply these two numbers together to get my answer. So 3 times 45 is going to give me 135 degrees for my answer. Okay, and just to clarify for those of you that are enrolled in my class, the key thing I want to make note of is if you are simplifying, make sure you are writing out the original. Okay, so showing me what you are multiplying it by. And then when you move into your next step, you can simplify. Maybe you rewrite the fraction and you simplify that way. That's fine too. Or you can do it and then just write out what you're multiplying. All right, so that was it for our lesson over radians on converting, as well as finding the arc length using our radians instead of degrees.